time is up.
So I called Trevor to see if he can troubleshoot from there.
Okay.
Because we have the same problem yesterday.
Okay. Yeah. Thank you.
Yeah, sure.
Well, many thanks for coming, and today we are making a big initiative, a very ambitious initiative of completing the quick refresher of practical steps for electron dynamics in limited time, shorter than 2 hours. So please try to stay within 10 minutes and for each. And the goal that each attendee of this meeting will be able to run non-adiabatic coupling either by Redfield approach or surface hopping approach. So we have total 7 presentations for about 1 hour 45 minutes. So there is a 5 minutes reserve, but it's better to try to complete quicker. There will be additional meetings to report your personal research update. There will be additional meetings to discuss theoretical background. So if you want to mention theoretical background, just make it quickly. Its main goal is to be able practically follow the procedure, which is challenging and long. And by helping each other, we will be able to repeat it and practice it for each of us for his or her system. So, as a little introduction, the thermal motion of nuclei spoil orthogonality of wave function and allows to dissipate energy of photoexcitation in electronic states into thermal vibration. This is very important because in addition to dissipation of energy, there could be transfer of charge carriers in space for photovoltaics or non-radiative pathway of recombination of these carriers for photoluminescence. So these two processes hardly rely on the dynamics, on how things develop in time. Therefore, this calculation is somewhat more challenging and complicated than regular computational chemistry techniques. So the talks are arranged in a following schedule: molecular dynamics, adiabatic couplings, converting couplings into rates, analyzing how the rates can be inserted into the code for propagation of electronic state, and then some observables, at least the photoluminescence observable. And at the end, there will be presentation on surface hopping method, which is beneficial if one need a little bit more precise details of electron dynamics. So with this, I would like to invite Daniel to present. Floor and screen are yours. And there should be a slide advancer here, right?
Yeah.
Okay, please go ahead.
Well, the topic I was given today was thermal heating and molecular dynamics. So with that, that does work. Okay. So I guess one of the first things that we do with heating and molecular dynamics is solve Newton's equation of motion. And well, the M stands for the mass, where the dr over dt will stand over the initial velocity of the ith nucleus, n, where there's a number of nuclei. Boltzmann constant, T is the temperature. So then the forces acting with each atom to a certain velocity is then used to solve the Newton's equation of motion. So so I guess one of the first things for inserting a heating job on VASP is to grab the template for the in-car. So here is the in-car. A couple of main things to look at is just to look at the temperature at the beginning, temperature at the end. So as the hashtags tell you, initial final temperature. So however you want to run your system, just move those. Something I gotta direct your attention to is end block. So what end block, and I guess number of cycles taken, they kind of relate to each other. So in this case, say we set the end block to 4. If we had our cycle at 100, so that's like take the numbers of cycle, divide that by the end block. So with the end block, what it does is we kick the molecule with the temperature that we have listed right there, and kick it a couple times, and then we'll let it relax for however many a number of ionic steps that we took it to set to, and we should get sort of graphic.
No, return back.
Yeah.
It's a technical, right?
Yeah.
So what is your S mass equals to -1? What other options? Why is it -1? What does it stays for? What if I choose 0? Or what actually choices are possible for S mass if I want to change it?
If you want to change it, so S mass, changing that would
And it tells you something there.
the velocities scale to each end block. So I guess it takes the inverse of the velocity since we have to set to -1.
And if I set it to 0, then it takes 0 velocities?
I assume that it wouldn't add any to the velocity, correct?
Is he the only one who's using this?
I guess I usually have to look these up, but would -1 mean that basically it'll set your first temperature at like 1 Kelvin, and then like 2 Kelvin, it'll basically work its way up? Is that what the -1 does?
I don't know.
Okay.
Jabin, you should know, right? S mass -1. He says it's because it's reverse velocity. If we set up S mass equals 0, then it takes 0 velocities. Is it true?
No.
Then what is this keyword stays for?
There is some equation is related with some other things. I need to look on the BAS website.
Equation for what?
This
It should be
equation
related to like the statistical process, like
is
canonical
how
versus like a
you define
microcanonical.
the temperature. It's kind of like that.
How you define the temperature, or how you
I
define?
mean, in other words,
Or how you define the
John, we heard you.
thermal
Good job.
mass?
It is
Yeah,
whether
kind of
it
like
is
that.
whether it is canonical or microcanonical ensemble.
Yeah.
So how you define your thermal mass or
Thermal-
thermostat around your system?
Yeah.
So technically it tells
I
you
think
you
they
can choose
muted
different
us.
algorithms. And 0 and -1 doesn't have direct meaning. for
Yeah,
value.
I'm pretty sure they
It's
did.
just the numbering of algorithms.
Same thing as last week.
And
The
I
only way
don't
they'll hear us
remember-
is if they
don't
switch us
remember
over, and I don't think it's ever
what
going to
are the
happen.
choices there?
They know I'm supposed to present at the end.
-3, -2, -1,
So
and then
no
anything
zero.
bigger than 0 or
Okay.
equal to 0.
So, and again, this is where noisy whoosy or no?
And
no-
there are some
no-
other relation with the
how you
positive
call it?
number?
Novi? Read it.
Okay, so for -1, in this case, the velocities are scaled to each end block step, starting at the first step.
But does it have a name for this type of algorithm? No? They don't put the name?
No, it doesn't mention
There
one.
should be
It-
noisy Hoover.
So, I mean, it tells you like how it assigns the temperature essentially. But yeah, there's not like a name for it. The S mass equals 1 is the like continuous increase or decrease
Braden,
in energy.
if you are hearing us, you may want to send an email because we
wait
are
a
not
minute.
hearing you.
You're
Microcanonical
saying no,
ensemble.
that's if it's positive number, then that's following that one algorithm.
Ah,
No, the
so there are positive numbers as well.
Yeah, yeah.
0
Anything greater than or equal
So
to
there
0,
are,
it's fine.
again, yeah. So again, it's not really how you define the temperature, because temperature is just defining your temperature kind of keywords, right?
Yeah.
It's a way how you really set up that this temperature, which is responsible for the surrounding, this is what we call a thermostat or thermal bus, interact with your system, right? And there are very many different mechanisms, very different algorithms are provided in a different way.
Yeah.
So if you read it carefully in the manual, you will see, like, would be good to kind of at least know what is the difference between them. Because it's always a question, which algorithm to use? Like someone just telling you use -1, but in the manual, you have many choices.
Yeah. Okay.
Why you blindly just believe to Dmitri's words? I never believe him. Just like this.
That's something to think about. Yeah.
So, okay, go ahead.
Yeah, I don't really know the rest of these other keywords. I guess like a cleanup that I kind of just blindly.
Well,
follow.
again, you have a block which really responsible for this molecular mechanics, how you set up your heating, right?
Yeah.
And then you have regular blocks which you will see in optimization and so on, how you calculate the electronic structure and so on, right?
Okay.
And this is your
Yeah.
next ones.
Of course.
So, and ionic, yeah. Are there any other questions? Like maybe like this is the right time if you're using this kind of setup, right? And you were looking at it carefully, checking this manual, and just wondering like why we choose, I don't know, ISIM equals 0, why sigma equals 3.5, why ISMIR equals 0. It would be really right time to ask. No? No questions?
What is L charge equal to false?
L charge equals false. Presume, I guess, I guess I really never looked into that. I just
Doesn't that just mean that you don't write the charge card file?
Mm-hmm.
overwrite the car charge file.
The charge car file.
Charge file.
Honestly, what you have to do, you have your file, you have your manual open on the website for the VASP, right? So you just go with a keyboard, searching for each of these keywords to check what is in your manual, what each of these values stays for, right? And what kind of other variables or what kind of other settings you can change. This is how you learn, because just using it blindly as a black box, because someone gives you the input file and not understanding what all these settings mean, is not the right approach.
Yeah, that's what you mean.
And again, all this information you can just get from a manual, very easy. You don't need to really even ask anyone. In a manual, you can, like, I guess London can answer now any of these questions just because he already opened the manual.
Yeah,
His laptop.
I spent plenty of time just like, oh crap, what does that do again?
Okay. So
Okay, let's pretend that we understand each of these keywords.
yeah. So changing the end block, like I said, however many steps you take decided. So what we do is since we set our file to
You need to explain what you have on the x-axis and y-axis because they're not marked.
Oh, well, okay. For the y-axis, it's just our temperature, and the x is the number of ionic steps that we took in. So originally we set temperature to 30 degrees. So what it means, like, and my end block was originally set up to 4. I guess I didn't set up those initial parameters. So we see in the 4th step, we kick that up with energy, it goes back down. And again, at the 8th step, we kicked it again, so it relaxes, then it goes back down. And that's just a little trend we follow if we want to interpret the end block. Yeah.
So changing end blocks means like you calculate in different end blocks, or
No, end block tells you how often you kick. You give extra energy to the electron.
so x is temperature, but temperature, so temperature and x is time step.
Yeah.
No,
They have nothing
y,
about
y
change.
is temperature.
Yeah, but they have nothing about the changing end blocks.
No. What I mean, like, if we change that initial parameter of end block, say we want 3 instead of 4, so on the 3rd step we would have seen a kick instead of on the 4th step.
Oh, maybe I missed something.
He just illustrates what this end block means. He's not changing. This is not with different end blocks. You just set up your end block equals 4,
Yeah.
and
Okay,
you see
that
this
title
picture.
actually
But again,
confuses
for
me.
explanation, probably you really should change the end block and show this picture with here is end block 2, here is end block 4.
Yes. I should have done that. Yeah, I guess I didn't really assume that.
Okay?
Thank you.
You're welcome,
So-
welcome.
So I guess another thing is the end card to the molecular dynamics. So initially you're just gonna basically grab. You can't run molecular dynamics till you run a heat job because it uses the velocities that was calculated in the heating job. So for sake of purpose, you just want to copy your POC card, your K points, and your comp card files from your heat directory. And you're just gonna rename the conc card to a postcard because the conc card has all your velocities that were calculated during the heating job. You just name that to your postcard and just copy. The only thing you don't have, but just initially grab is just the in-card template. So something I gotta mention to you too, a little tip is the PTOIM. If we decrease that and we increase the number of cycles, Results will lead to a higher resolution whenever it comes to making our molecular dynamic video, which is really interesting to see because we get to see what your reaction, what your cell would do in that case. So for your temperature, you just want to basically use the same settings you use for your heating job, and after that, you just, when you want to make a movie, just grab a software such as BMD. Whenever you go to the movie generator in there, just select your settings and how you want it to rotate or keep it in one view. Just change your settings from there, and then from the format, just choose whichever format you're gonna use to visualize present it. Like, I guess if you use like Windows Movie Maker or something, or Media Player, you can just choose any setting you want. I think runs it all, and that's usually about it for heating and molecular dynamics. Is there any questions?
Okay, well, thank Daniel. Being quick, do not disappear. There could be more questions. Oh, I have one. So, looking forward to next talks, what is the main set of data? Which information is transferred to the next stage of computational protocol? Like, which data from your molecular dynamics calculation London will start with in his compilation of coupling? Huh?
Spin coupling?
Which data of your molecular dynamics calculation are transferred to the next stage?
Would it be the velocity?
Do not rush. Think for a couple of seconds. You have all the information. So you've told that results of your molecular dynamics calculation can be visualized in the form of movies, right?
Yeah.
So what is movie? What is shown on the molecular dynamics movie?
I guess how your atoms will move around in a certain amount of time.
Okay. And mathematically, what does it mean? Atoms move around.
Well, how they want to be, I guess, situated to their form of reaction.
Position of each atom in space changes with time. Coordinates change in time.
Coordinates change with time.
Yes. So in which files are they stored?
Wouldn't it be in econ-car?
In quant-car, you have only the last set of coordinates. But if you need to, what do you insert into your molecular dynamics visualization?
The postcard?
Postcard has only initial. Like, quant-car has only the final. And in your molecular dynamics in-car, you told that you request 1,000 steps of dynamics. Where are these 1,000 sets of coordinates?
Guess it'd be written in the out car. Well,
Yes, everything is in our car. Or you can store them into the movie file with some scripts. And probably there should be scripts to store each snapshot of coordinates in a separate file, right?
not that I'm aware of yet.
But we would like to have such too, right?
Yeah, sure. I mean, it sounds like it's helpful.
Okay. Hopefully London will help us to answer this big puzzle.
We just so happen to be in luck.
More questions to Daniel? If not, let's thank him once again. So all files there are uploaded and numbered by sequential number and name of the presentation.